Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at how to find the sine, cosine, and tangents of specified angles of a right triangle. To get us started, let's go ahead and refresh our memory on our three trig ratios. We're going to be making use of the acronym SohCahToa to help us to remember how to find the sine, cosine, and tangents of specified reference angles. So let's say we have this given right triangle here, and let's say we have a reference angle theta. So with this configuration, we can find the opposite, adjacent, and hypotenuse. All right. So with whatever reference angle you're given, the side that's opposite that angle is known as your opposite. Okay, let's call it OPP period. And then opposite your 90-degree angle is the longest side of the triangle, of the right triangle, called your hypotenuse. And then the third side is called the adjacent. All right, so what does SohCahToa tell us? The first three letters, SOH, S-O-H, basically tells us that S is for sine. Sine of the reference angle theta is the opposite divided by the hypotenuse. All right. So O in SOH is opposite, H is hypotenuse, S is sine. And then the next ratio, CH, tells us that C is for cosine of the reference angle, A is for adjacent over the hypotenuse. Okay. And then lastly, we have TOA. All right, what does that mean? T is for tan. Tan of the angle theta is equal to O is for opposite, and A is for adjacent. All right, so these are the three trig ratios that we're going to be finding for the specified angle in the next set of problems. All right, instructions for the examples that we're going to work on are for us to find the sine, cosine, and tangent of angle A. Okay. All right, so let's go ahead and take a look at question number 1. So let's label it A, B, and C. So let's say this vertex is A, and then this is B and C, and then this is the right angle, and then this side is 16, 9. All right, so for question 1, we want to find the sine, cosine, and tangent for this triangle right here. Okay, so in order for us to find the sine, cosine, and tangent, we need to have all three sides. Okay, but if we take a look at the situation that we're dealing with, we have only two sides. So let's go ahead and mark the side. So this is the reference angles that we're dealing with right here. So angle A. So this is the reference angle. This side right here is the opposite. Okay, we can also call that A. And then the side opposite the 90-degree angle. So let's mark this. So this is right here is the opposite side. The side opposite the 90-degree angle is your hypotenuse. Let's call that C. And then you notice that this other side right here, the adjacent, or B, is an unknown. We don't know what it is. So to find all three trig ratios, we will need to find the third missing side, namely the adjacent. Okay, so to do this, let's do what we wanna. Let's state what we have first. We have the opposite is 9. The hypotenuse is 16, and the adjacent is unknown. So the first task is to find the adjacent. Okay, we want to find the adjacent, which is C. So find the adjacent C. Adjacent C. Okay, so let's do that. So in order to find the missing side of a right triangle given two sides, you don't need trig for that. You can just simply use your Pythagorean theorem, okay? So a squared plus b squared, the sum of the square of the legs. Notice we enabled the legs a and b here, so these are the legs. The sum of the square of the legs is equal to the square of the hypotenuse. A squared plus b squared equals c squared. All right, so let's go ahead and find c. So a is 9, so we have 9 square plus b square, we don't know what that is, equals c square 16 square. All right, so let's work this out. 9 square is 81, 9 times 9 is 81, plus b square equals 16 times 16, that's 256. All right, now what we're going to do is get b squared by itself, so we'll subtract 81 from both sides of the equation. This is a quadratic equation. So subtract 81 from both sides. So that's going to give us b squared is equal to 175. All right, so now to get b by itself, we'll simply take the square root of both sides of the equation, since the inverse of square is square root, so root both sides. And then we're going to have b squared, b is the square root of 175. So let's see, can we reduce this, simplify it further? So we have a multiple of 5, since the number ends up in 5, so we can factor out of 5. 5 goes into 175 35 times. 5 goes into 35 7 times. All right, so we have a perfect square here. So the square root of 5 times 5 is the same thing as the square root of 25, or 5 squared. So that comes out as a 5. And this one stays behind. Okay, so the simplified state of b is going to be 5 root 7. Okay, so now we have all the three sides that we want, so we can now proceed to find all three trig ratios. So the first one is sine. Sine of, we're looking for sine of angle A. That's the reference angle for this problem. Let's put in the missing measure that we just found. We found out that b is 5 root 7. Okay. So sine of A, using SO in SohCahToa, let's write it again, just in case you forgot. SohCahToa. So using SO in SohCahToa, sine is opposite over hypotenuse. So the opposite is, let's see, 9 over your hypotenuse, which is 16. All right, there are no common factors, so that's the final answer. And then cosine. Cosine of angle A is your adjacent over your hypotenuse. Your adjacent is 5 root 7 over your hypotenuse, which is 16. So you look at the number in front of the radical and the number in the denominator, they have nothing in common, so that's that. And then lastly, tan. Tan is opposite over adjacent. So the opposite is 9 over the adjacent, which is 5 root 7. Now you may not have a radical in the denominator position, so we have root 7 that has to be rationalized out or simplified. So to get that simplified, we will multiply by the conjugate, so root 7 and root 7. All right, so just to rationalize out the denominator, so if we multiply that out, we're going to have 9 root 7, all right, over, so 5 times root 7 times 7 is root 7 square. Or you can write it as root 49, it doesn't really matter. But the bottom line is that you're going to be having the square of a square root, so those two will cancel out. And then you're going to have, let's put it over here. You're going to have 9 root 7 divided by 5 times 7. Okay, and then that will give you 9 root 7 over 5 times 7, which is 35. And there goes your tan right there. Okay. All right. Now let's take a look at question number 2. So for problem 2, let's say we have a right triangle like this. And then this is C, A, and B. And then this side is 2 root 3. This side right here is 2. And you have to find all three trig ratios. Okay, so how do we do this? Let's go ahead and set this up. So remember the process. In order to find all three trig ratios, we need all sides. So what are the sides that we have? Since this is a reference angle, the side opposite it, that one is going to be called your opposite. Or we could call it side A. Okay. And then the side opposite the 90-degree angle, as always, your hypotenuse. The longest side is always the hypotenuse, or you can also call it C. And then the adjacent is missing in this problem. All right. So what is the adjacent, or little b? We don't know. Let's find it. So we have opposite is 2. Our hypotenuse is 2 root 3. And the adjacent is unknown. So let's find the adjacent. Find the adjacent. Okay, find the adjacent B. Oh, in the other problem we called it C. It was supposed to be B. So supposed to find the adjacent B. Okay, so let's do it. We're going to be using the Pythagorean theorem to do this. A squared plus B squared equals C squared, like we did previously. So A is 2, so 2 squared plus B squared. B squared is unknown, equals C squared, which is 2 root 3 square. All right. Let's simplify that. We're going to have a quadratic equation given by 4 plus B squared equals. Now to square this, we're going to square the 2. And we're going to square the root 3. Okay. When you square the 2, you're going to have 4. When you square the root 3, you have the square of a square root, so they cancel out and you have 3. Just like in this other part here, when we multiplied root 7 and root 7, we had the square root of a square. Anytime you have the square of a square root or the square root of a square, they cancel each other out and you're left with that radicand piece. Okay? So we're going to have here 4 plus b squared equals 12. All right, moving right along. To find b, we have to get b squared isolated first, and then we'll root it using the square property to finish it off. So let's see what we have here. Subtract 4 from both sides. Okay, when we do that, we're going to have b squared is equal to 8. And then to get b by itself, we're going to take the square root of both sides, square root. And then b is going to be the square root of 8. Now, can we simplify root 8? Let's try it out. Are there any perfect squares as a factor of 8? So take out 2. 2 goes into 8 4 times. Take out another 2. 2 goes into 4 2 times. Oh yeah, we have a perfect square here. 2 times 2 is 4. Or 2 squared. And when you root that, you just get 2. Okay? And then this one stays behind. So the simplified state is of 8 is 2 root 2. So now we have our adjacent, or little b is 2 root 2. So we can now find all 6 trig ratios. Okay, so let's go back up here. The missing side that we just found is 2 root 2. Okay, so let's do it. Sine of A using SohCahToa again. Hopefully you haven't forgotten yet. SohCahToa. Sine is opposite over adjacent. Nope, opposite over hypotenuse. Opposite over hypotenuse is sine. So sine is opposite, which is 2 over hypotenuse. The hypotenuse is 2 root 3. So we have a square root in the denominator. So we have to simplify that by rationalizing out the radical piece. So since you have a root 3 down here, you multiply by root 3. That's how you get rid of the square root. Because in number 1, in the 10th part, notice we had a root 7 down there. So we multiply by root 7 top and bottom. That's how you rationalize, okay? So this will now become 2 root 3. And then on the bottom, you're going to have 2 times root 3 times root 3, or root 3 square, or root 9. Square and the square root cancel out again. So you're going to have 2 root 3. And then you multiply the 2 and the 3, and then you get 6. Okay? Now you notice that 2 goes into 6 3 times. So 2 goes here 1, 2 goes here 3. So it's going to be root 3 over 3. That's your sine. Okay. Cosine. Cosine of A is going to be Ca adjacent over hypotenuse. All right. And then here your adjacent is 2 root 2. And your hypotenuse is 2 root 3. Okay. Oh, if you notice here, the 2's, there's a 2 here and a 2 here, so you can divide that out. Okay. And then you are going to have root 2 over root 3. Now, you can't have a square root in the bottom, so we have to rationalize that out. So root 3 and root 3, top and bottom. And on the top, you're going to have root 6. And on the bottom, you're going to have root 3 squared, which is just 3. Okay, so the shortcut is this. Keep this in mind. If you multiply root A times root A, it's going to simply be A. All right, that's what we did down here. Notice root 7 times root 7 is 7. We did that over here. Root 3 times root 3 is just 3. Okay, so there you have it. All right, so there goes cosine. And then the last one is tan. Tan A is opposite over adjacent from TOA. So your opposite is 2 over your adjacent, which is 2 root 2. Okay, this can be reduced. The 2's divide out, so 2 goes here 1, 2 goes here 1. So you get 1 over root 2. But you cannot have a square root in the denominator position, so you have to simplify that out. 1 over root 2. So to simplify that out, you multiply, you rationalize the denominator root 2 root 2. And you will get your final answer, root 2 on the top. And then what do you think root 2 times root 2 is? It's going to be root 4 or root 2 squared, which simplifies simply to 2. Remember the rule, root A times root A is just simply A. And there goes your tan right there. So there you have it. That's how you find the three trig ratios of a specified angle of a right triangle.